Let's explore backups in Spanner. Why backups matter? Backups safeguard against operational mistakes arise due to logical data corruption from operator or application errors. Hence, they help us to protect the data. Backups also ensure your application can always recover from a catastrophic event, ensuring the business continuity. And backups also fulfills archival and compliance requirements with retention up to 1 year. Moving to timestamps. Timestamps is a crucial concept in Spanner. We have two kinds of timestamp, create time and version time. Create timestamp is a timestamp when Spanner receives the request and the backup operation actually begins. So you can say it is the start time. While version time is the precise moment database is captured, guaranteeing a transactionally and externally consistent state for restoration. You get a clean, transactionally sound copy of all rows across all the tables. This eliminates the need to worry about partial transactions or inconsistent reads, which is often a challenge when we take backups in distributed systems. So if a database has 100 tables in a distributed environment, the version time guarantees that all the tables and data are in externally consistent state at that moment of time. Let's see the examples while talking about backup types. We have two kinds of backups, on-demand backups and scheduled backups. On-demand backups are the manual backups which are requested by a user. Here, we can have only full backup. By default, create time and version time are same for these kind of backups. It means if you have requested a manual backup at 7 a.m., create time will be 7 a.m. because backup operation begins or starts at that time. However, version time will also be 7 a.m., meaning that the backup has data which is in externally consistent state at 7 a.m. While requesting manual backup, you can also specify an older version time, but it should be within the database's version retention period. Scheduled backups are automated backups. It can be full backup or incremental backup. Spanner offers incremental backups for our database through a backup schedule only. You cannot create an incremental backup on demand. Here, create time occurs in 4-hour window after the scheduled version time. So if the scheduled version time is 7 a.m. IST, backup can start anytime before 11 a.m. IST. Irrespective of the create time, version time will remain same as 7 a.m. IST. The reason Spanner has this 4-hour window because Spanner starts backup operations as per their available resources. One thing to note here is that there can be maximum 4 backup schedules per database. Moving to default backup schedules. The default backup schedule is a feature that can be enabled for all new Spanner instances. It is designed to give you instant baseline protection against major data loss without requiring manual configuration. This schedule creates a full backup of every new database in the instance every 24 hours. The retention period for these default backups is 7 days. This is the setting applied at the instance level. When you create a new Spanner instance, you can specify whether you want this default policy applied to all future databases created within that instance. Default schedules only apply to new databases created after the schedule is enabled on that instance. They do not apply to existing databases in that instance. One thing to note here is that default schedule takes 24 hours to become active and start creating the first backup. You should confirm the first backup is created before relying entirely on this default protection. The default backup is just a starting point. Once the schedule is active, you have full control. You can edit the frequency or retention period or delete the default schedule entirely. One thing to note here is that before you delete an entire Spanner instance, you must manually delete all backups associated with it. So you can see here in the default backup schedule, when we create an instance, we get the option to enable default backup schedules. Moving further, let's see what is included and excluded when we take a backup. A cloud spanner backup is a single external consistent artifact that allows you to restore the database in its entirety. It captured three critical components: the structure, that is schema, the data, and the configuration. The schema includes all table definitions, indexes, and change stream definitions. Data is the most critical part of the backup. The backup is taken at a globally consistent timestamp known as the version time, which we have already discussed. This means that no matter how many nodes or region the database spans, the backup represents a state where every transaction that committed before the version time is included and every transaction that is committed after is excluded. You get a clean, transactionally sound copy of all rows across all tables. This eliminates the need to worry about partial transactions or inconsistent reads, which is often a challenge when backing up distributed systems. Beyond the data and structure, the backup also saves the specific operational settings and features which we have enabled for the database. These are the configuration items which we set in the schema using alter database set options command. Some examples are time to live policies. Now, if we have defined policies to automatically delete old rows from tables, these policies are included. We define these policies in the schema. Backups also maintains the preferred leader region setting if the target instance supports it. For a successful recovery plan, knowing what is included is as important as knowing what is excluded. Now let's see what is excluded in the backups. Instance configuration is excluded from a spanner backup. The backup is only of the database, not the instance hosting it. So you must recreate or have the appropriate instance ready before you can restore. Permissions and security related definitions are managed outside of the database itself. Hence, they are also excluded. Certain ephemeral or non-relational elements are also excluded from the snapshot, for example, sessions or cache data. Any services or data sources that integrate with the spanner but reside outside of the database are not included. Moving further, full versus incremental backups. Full backup stores the entire database at the version time, while the incremental backups contain only the data that has changed since the previous backup in the chain. Now let's spend some time to understand the chain concept. Incremental backups form chains between full backups. The first backup in a new chain is always a full backup. Consecutive backups in the chain are incremental backups. Each one contains only the data that has changed since the immediately preceding backup in that specific chain. You can think of it like a train. The full backup is engine and each incremental backup is a new car added to the backup containing only the new freight. A spanner permits up to 13 incremental backups per chain in addition to the initial full backup. When a chain reaches its maximum length, a spanner automatically starts a new chain, beginning again with a fresh full backup. Each chain is uniquely identified by the field incremental backup chain ID. This ID helps spanner to keep track of the dependencies. There are the scenarios where spanner start a new chain even before the 13 backup limit is reached. Let's see those scenarios. The oldest full backup was taken 28 or more days ago, or the newest backup in the current chain is deleted, or the incremental backup schedule itself is modified. In all these cases, the spanner proactively starts a new chain even before the 13 backup limit is reached. So you see, spanner is smart enough. Now, restoring an incremental backup requires all older backups in the chain to be present. If even one of the backup is missing, the chain is broken and newer backups cannot be restored. If you delete a backup or if it expires, a spanner might still keep the underlying data if it is needed to support newer backups in the chain. To completely remove all data in a chain, you must delete all the individual backups in that specific chain. Incremental backups only support Google owned and Google managed encryption keys. This is true even if the primary database uses a customer managed encryption key. Restoring an incremental backup might take longer time than restoring a single full backup that contains the same amount of final data. It happens because a spanner must sequentially process and apply all the changes from the chain links. In case of retention, the oldest full backup in a chain is retained past its original expiration date if newer incremental backups still depend on it. This protects the chain from being broken prematurely. When you copy an incremental backup to another region, Spanner automatically copies all older required backups in that chain. If the destination already has part of the chain, it may be from a previous daily copy, Spanner only copies the new incremental backup and appends it to the existing chain. It helps Spanner to avoid redundant copies and saving on the copy cost. Now let's understand this cost with an example. Consider we are having a 100 GB database and 10 GB new data is being added every day. So if we opt for a full backup schedule in every 24 hours, we will end up having 600 GB backed up data over 5 days. How? 600 GB initial data and then every day 10 GB data is being added. But every day the whole data is copied. It's a full backup. So first day 100 GB, second day 110 GB, third day 120 GB, fourth day 130 GB, and fifth day 140 GB. So total 600 GB. But if we opt for incremental backup only, then we are going to have 100 GB data and then total 40 GB data added over 5 days, which will result in 140 GB. So you say how much we can save the cost for the storage. Moving further, let's see the availability and replication of the backups. Backups are automatically replicated within the same geographical location as the source instance. In case of a single region configuration, backup is stored in each of the 3 read-write zones. Or in case of dual or multi-region configuration, backup is stored in all zones that contain a read-write or read-only replica. A backup resides in the original instance. It is not automatically copied to another region. If we have to move this backup to another region, we need to use the copy utility. We can copy backup to a different region or project for business continuity or for protection against regional outages or for compliance purpose. This copy is critical for disaster recovery planning. Moving further, backup deletion. All backups have a user-specified expiration date which determines when it is automatically deleted. Spanner deletes expired backups asynchronously, so there might be a lag between when a backup is expired and when it is actually deleted. When you delete a backup in an incremental backup chain, you cannot recover storage if there are newer backups present in the chain. The newer backups depend on the data present in the deleted backup and the older backups in the chain. Moving further with performance and cost. Backup creation is a separate job that does not use CPU resources allocated to the database's instance. It means no impact on database performance. Most backups and copy completes in 1 to 4 hours, regardless of the database size. Billing is based on storage used per unit time. So billing starts after completion and it has a 24-hour minimum charge. When we copy the backup to another region, we are billed with outbound data transfer cost. However, Spanner tries to optimize this to minimize the transfer.